All right, so when we learned about finding the domain, there were two things that restricted the domain. One was having variable in the denominator, and the other was having a variable under an even root. And so this is one of the situations where there is an even root. Do you guys remember what you do with that 8 minus 2x? What can you not have underneath an even root? A negative. So that has to be greater than or equal to 0. And then you're just going to solve that for x by subtracting the 8 plus 2 and dividing by the negative 2. But there is something special you have to do if you divide by a negative. Do you guys remember what it is? Switch the sign. So the greater than or equal to becomes a less than or equal to, and that's the domain of that function. You have to only put in numbers that are less than or equal to 4. Otherwise, you'll get an error. You'll get something that's undefined. All right, and then for b, we have f of x equals x over x plus 2. This one has the other thing that restricts the domain. We have a variable in the denominator. Now, does this x in the numerator, does it matter at all for your domain? It doesn't. We don't care. All we care about is this. So what can your denominator not be? 0. So we'll just say that whole denominator does not equal 0. So what does x not equal? Negative 2. So we can put any number in for x except negative 2. What if you don't have an even root and you don't have a denominator? What's your domain? All real numbers. Very good. Okay, so these are the two I want you guys to do. For number 1, you're going to find the domain of f of x equals 2x over x squared minus 9. That's a little more challenging than the one I did. And then for number 2, f of x is the square root of x plus 6. All right, there's actually two things x cannot equal on number 1. What are they? 3 and negative 3. So those are the two numbers you can square, subtract down from, and get 0. So I'll write it out. So we move that 9 over, but whenever you do the square root, you always have to take the positive and negative square roots. That's why you get 3 and negative 3 kicked out of the domain. And then what about number 2? What does x need to be greater than or equal to? Negative 6. All right, any questions on this? Okay, then after we talked about domain and range and kind of at the same time, we also added, subtracted, multiplied, and divided functions. And so that is what the next question is. I'll let everybody get caught up with that one. All right, so for C, we're going to let f of x equal x squared plus 2x minus 4, and g of x equals x minus 8. And we're going to find f of x minus g of x. Okay. So that just means I'm going to take f of x, which is that big trinomial, and I'm going to subtract g of x from it. And anytime you have either a number in front of the parentheses that you would need to distribute or a negative in front of the parentheses matter. This first set doesn't matter, so we can just drop it off because there's nothing being multiplied by it. There's no negative in front. But the second set, you have to distribute that negative. So we're subtracting both x and we're subtracting negative 8. And when you subtract a negative, it's the same as adding. If you think about like when you owe money, if you subtract a negative, you're actually adding to it. Okay, and now it's just combining like terms. So we have 2x minus 1x, and then negative 4 plus 8. Alright, so I'm going to have you guys do 2 of these, but I'm just going to give them to you one at a time. So for number 3, f of x is 3x squared minus 4x plus 1. G of x is x squared plus 5. And you guys are going to find f of x plus g of x. Now adding is great because the parentheses don't matter at all. So we just straight add like terms. And that's it. That's all we have to do. Alright. I'll have you guys do a division one. And division looks like it's going to be difficult, but it actually is the easiest one to do, I think. So this time, f of x is 3x plus 1, and g of x is x minus 4. You're going to find f of x divided by g of x and its domain. So it's another domain practice problem. Bless you. Alright, so when you do the division, all you do is just put one on top of the other and you're done. You don't have to do any combining, that's it. But we do need to find the domain. So what's the one thing x cannot equal? What x would make you have 0 in the denominator? Yes. So you can set it up. X minus 4 does not equal 0. So x does not equal 4. Okay. And then after we talked about combining functions, we talked about composition of functions. And so even if you're not like writing the notes, I do want you to put this table on your paper, because we're going to use this one for the examples and for the ones you guys are going to do. So there's going to be a column for x, a column for f of x, and one for g of x. Right, and then x is just going to go from 0 to 5. Alright, and then f of x going down is going to be 5, 3, 1, 4, 0, 2. And then g of x is going to be 2, 4, 0, 1, 5, 3. Alright, and then for D, we're going to find f of g of 1. Okay, and so if you guys remember when we did this, we always started on the inside. So if I want to find f of g of 1, I'm going to start with g of 1. So when x is 1, g is 4. And then we find f of 4. When x is 4, g is 0. And that's it. Alright, for E, we're going to do g of f of 0. So starting on the inside, f of 0 is 5. And then g of 5 is 3. Okay, so I'm going to give you guys 2 to do. For number 5, I want you guys to find f of g of 4. And then for number 6, g of f of 3. All right, what you guys get for number 5? Two? Am I looking at the wrong thing? It's 2. I'm pretty sure. All right, so g of 4 is 5. And then f of 5 is 2. All right, what about 6? Nobody wants to tell me? Did you guys get 5? Okay, so f of 3 is 4, g of 4 is 5. All right, after we did that, then we did compositions with expressions. So we did that with tables and graphs. I think probably on your test you'll have tables and graphs to do that with. But then we moved on to expressions. So for f of x is x squared minus 4. G of x is the square root of x minus 6. And we're going to find f of g of x and g of f of x. Now, on your test, I think you'll just have to do it one way. But I want to show you an example of both. All right, so we're going to start off with f of g of x. So that means we're going to take what g of x is, which is the square root of x minus 6, and we're going to put it into the f function. And everything I put into the f function, will you just set it down? That table right there, thank you. Everything I put into the f function, I'm going to square, and then I'm going to subtract 4 from it. So that's what I'm going to do to x squared minus 6. I'm going to square it, and then I'm going to subtract 4 from it. So what happens when you square a square root? I can't tell if you don't want to talk to me, if you don't know. A square will like undo a square root. It makes it go away. So that you're just left with x minus 6, and then you still have that minus 4. And then when you combine the like terms, you're going to get x minus 10. That is what f of g of x is. All right, and then sometimes you're asked to find it the other way. You want to find g of f of x. So that means I'm going to take what f is, which is x squared minus 4, and I'm going to put that into g. So instead of under the square root having x minus 6, we're going to have this whole thing minus 6. So I still have this square root, and then it's going to be x squared minus 4, and then the minus 6. All right, do these parentheses matter? Right, they don't. They only matter is if there's a negative in front of them or you're multiplying them by something. So we can just ignore the parentheses and combine those and get x squared minus 10. And that's all we can do. We can't like take a square root because of that, because of the minus sign, so we're done at this point. All right, you guys ready to try one? All right, I'm going to have you guys do number 7. I'll leave that up there so you can see it. So number 7, f of x is the square root of x plus 2. G of x is the x squared minus 2. And you guys are going to find f of g of x. All right, and then that one just simplifies down to x. All right, any questions? Now that one we can, because there was no, like here I said you can't do the square root because of that subtraction. If there's no subtraction, it's just the square root of x squared, that's just going to be x. All right, and then after we talked about compositions, we talked about inverses. And that's what G is. Does anybody need to see 7 longer? Are y'all good? Okay. So G, f of x is going to be the cube root of x minus 4. And we're going to find f inverse of x. All right, finding the inverse, there's 4 steps. 3 of those steps are like crazy easy. One of those steps can be kind of challenging. So the first step is to replace the f of x with what it stands for. Which variable does f of x stand for? It just stands for y. All right, then what do we do to find the inverse? You're going to switch x and y. All right, 2 easy steps. Then this step is the one that takes a while to do, and it's got all the algebra in it. So we need to do whatever we have to do to solve for y. So what would you guys do first to get to y? Cube, yeah. If you want to get rid of a cube root so we can get to y, you have to cube both sides. And cubing just gets rid of that cube root, and you're left with what's underneath, which is y minus 4. And then your last step would be to add, well, almost last step, would be to add the 4. The actual last step is to write it in inverse notation. So that's the function that undoes everything this one did to the problem. Okay, and let me give you guys what to do. Try to have most of it up there if you need to see the steps. So this is number 8. F of x is the square root. This is kind of tough. The square root of x squared, the square root of x plus 6. And then outside is a minus 4. And you guys are going to find F inverse. So don't forget, switch x and y, and then solve for y. So the step where you square both sides, I don't think we practice very many of these. You have to square that as one big quantity, and you don't actually, we're not going to multiply it out. So we're going to leave it as x plus 4 quantities squared. And if this one was on your test, it'd be multiple choice, and you'd be able to look at the answers and just kind of know that's what's going to happen. All right, and so our last step is to write this in inverse notation. So that should be the inverse. So like if we put 30 in for this x, that would give us 2. And so for the inverse, you should be able to put in 2, and it would give you 30. So it would just turn the 2 back into the original number. All right, and then the last thing, well, before piecewise functions, we don't have time today to do piecewise functions. After we did inverses, we did graphs of inverses. And one of the things we did is we would have the original functions graph, and we would tell the inverses domain and range. So you're going to have some of that on your test. So we are given the graph of g of x. Find the domain and range of g inverse of x. Okay, so g is going to have an endpoint at -1, -2, and it's going to curve up and to the right. All right, now it's highly likely you can go straight to the inverse domain and range, but I just want to remind you of what you do. So I'm going to start with the domain and range of g of x. And so the smallest x value where you have something graphed is -1. And then it's going to keep going forever to the right, which is going to go to infinity. And then the lowest value of y that you have something graphed is -2. And then it's going to go up forever, so it's going to go to infinity. So then what do I do to find the domain and range of the inverse? You just switch them. Because it's all about switching x and y's. When you switch x and y's, you're switching domains and ranges. Alright, so let me give you guys one to do. This is 9, the last one. So same directions. Alright, this time our endpoint is at -3, 1. And this is f. So I want you guys to find the domain and range of f inverse. Alright, so as soon as you guys check your answers on that, make sure your name's on your paper and turn it in, please.